We know we can use the explicit equation formula to find unknown values in an arithmetic sequence. Let's review how to use the recursive equation formula to find unknown values in a sequence. And we know that this always uses the preceding term to define the next term of the sequence. So here, for example, we have a sub n equals a sub n minus 1 plus d, which is the difference. A sub n is one term ahead of a sub n minus 1, and this a sub n minus 1 is always one term behind. Let's explore this further. Here we have the recursive equation formula. Let's say that the given is a sub 1 equals 7, and the difference is 3. So we know the first term is 7. How do we figure out what the second term is? And again, the third, fourth, and 5. Let's say we have to do 5 iterations. How do we go about doing that? We're simply going to plug in these numbers into our recursive equation formula. So here we have a sub 2 equals a sub 1, which is n minus 1 plus d. So we know that a sub 2 equals a sub 1, which in this case is 7, so we're going to plug in 7, plus 3, plug in the difference, and that's going to give us 10. So 10 is the same thing as a sub 2. Tremendous. What about a sub 3? We know that it's a sub n equals a sub n minus 1. So a sub 3 equals a sub 2, which is the same thing as 10 because we just figured that out. And then 10 plus the difference equals 13. And so if we sort of zoom in over here, what do we know? We know that a sub 3 equals 13. We just figured that out. So what's a sub 4? That's 13, which is a sub 3, plus 3, the difference, and that's going to give us 16. A sub 5 is a sub 4 plus 3, giving us 19. So what would a sub 6 be? That would be a sub 6 equals a sub n minus 1, which is 19. The preceding term value is 19, plus 3. 19 plus 3 is 22, and that is the value for a sub 6. So let's say that we're just given these values. A sub 1 equals 5, and d equals negative 8. The difference is negative 8. What we need to do is we need to write that into our recursive equation formula, which is going to look a little something like this. So we know that it's a sub n equals a sub n minus 1 plus negative 8. So we're going to pop in the negative 8 into this area of the equation, and then a sub 1 equals 5. We know that because it's right here. So now we're ready to work. We're ready to find the second value in this sequence. So what is a sub 2? Well, that's going to be a sub 1, which we know is 5. So it's going to be 5 plus the difference, which is negative 8. So 5 plus negative 8 gives us negative 3. So a sub 2 equals negative 3. A sub 3 is what? That's going to be a sub 2, which is negative 3, plus negative 8, giving us negative 11. Tremendous. A sub 4 is the value of a sub 3, which is negative 11, plus negative 8, giving us negative 19. And then what would a sub 5 be? So a sub 5 is going to be negative 19, or a sub n minus 1, right? Plus negative 8, giving us what? Negative 27. Things can get a little bit tricky when there are fractions involved, so let's explore this. Let's say, hypothetically, the very first term of the sequence is 1/2, and the difference is negative 1/3. But what we need to do is we need to make the denominators the same, and to do that, we're going to be multiplying the first term by 3 on both the top and the bottom, the numerator and denominator, and that's going to give us 3 over 6. So this is our first term. What about the difference? It's going to... Likewise, we need to make sure that the denominator is the same. We want 6 on both sides. So we're going to multiply both negative 1 and positive 3 by 2. And when we do, negative 1/3 becomes negative 2/6. And now what we need to do is take this new information and pop it into our recursive equation formula. So it's going to be a sub n equals a sub n minus 1 plus the difference, which we know is negative 1/3 because we actually found that right there. Alternatively, we're going to change that into negative 2 over 6 in a minute. And here we've got the first term, which we're going to change into our conversion, 3 over 6. So now, what I know is we have a sub 2 equals our a sub 1, which is 3 over 6, plus the common difference, which is negative 2 over 6, and that's going to give us 1 over 6. So this is the second value in this sequence. A sub 3 equals a sub 2, which is 1 over 6, we just figured that out, plus the common difference, the same every time, giving us negative 1 over 6. Negative 4 equals negative 1 over 6 plus the difference, negative 2 over 6, giving us negative 3 over 6. So that's the fourth term in this sequence. But what if we're not given the first term or the common difference, and instead just given two random values and a sequence? For example, a sub 13 being equal to 263, and the 38th term, a sub 38, equaling 763. How do we approach this? Well, we know that we've got our recursive equation formula, and that we're going to need to plug in some values, right? We're going to need to figure out what the first term value is and what the difference is. So let's say, again, that we've got the 13th term and the 38th term. What we're going to need to do is, in order to write this equation and find the first 5 terms, is we're going to have to find the common difference, and then we're going to have to find the first term. We're going to use this formula to find the common difference, which is a sub f, our final, minus a sub I, the initial value, divided by final over initial, and those are the counts in the sequence. And what is that going to look like? So, for example, we're going to plug in 763 because this is the a sub f value, minus 263. We're going to plug this in over there, over a sub 38, the 38 minus 13. We're going to plug that in. And when we plug in those values using this formula, that's going to give us 500 over 25. And when we simplify, that's going to give us 20. 500 divided by 25 is 20. That's our new difference. Great. So we found that first crucial ingredient. Next, we need to figure out the first term. And we're going to take that new value, right? So we know we've got the difference. And we're going to go back to the explicit equation formula. And we're going to use this first value in the sequence. So we know that a sub 13 equals 263, right? So let's pop that information into the explicit equation formula. And a sub 13 equals a sub 1 plus d times n minus 1, or 13 minus 1. And we can then swap out a sub 13 to 263. We know that because these are equal, right? So we can simply exchange them that way. So 263 equals a sub 1 plus 20, the difference, times 13 minus 1, which of course is 12. And 12 times 20 is going to give us 240. And we know that 263 equals a sub 1 plus 240. And if we subtract 240 from both sides, that's going to give us 23. So now we found the very first value in this sequence, which is 23. We're not out of the woods yet. We now need to plug that new information, right? We just found out 20 is the difference, common difference. 23 is the first term. Let's just jump in. So here we have our recursive equation formula. We have the difference, and we've got the first term. And so now how do we figure out what the second term is? We're going to write a sub 2 equals a sub 1, which we know is 23, plus the common difference, which is going to be the same every time, plus 20, and that's going to give us 43. So we found the second term. The third term is the second term, in this case 43, plus the common difference, equaling 63. What's the fourth term? The fourth term is a sub n minus 1, aka 63, plus the difference, giving us 83. So what would a sub 5 be? A sub 5 is going to be 83, right? We're grabbing that right here from a sub 4. We're going to add 20, which is the common difference, and 83 plus 20 is going to give us 103. That is the fifth iteration. Let's go through one more. So let's say we know that the 10th term is negative 310, and let's say that the 31st term is negative 940. What we're going to need to do is use that new equation, AF minus AI over F minus I. And when we do, we can plug in that information. We've got the final value minus the initial value, so negative 940 minus negative 310, divided by the final count, which is 31. We got that from right there, right? Minus the initial count, which is 10. That's going to give us 630 over 21. And using your handy-dandy calculator, you can figure out that the simplified answer is just negative 30. So you got our difference. Great. Next, we got to find the first term. We're going to go back to our explicit equation formula. We know that let's say we're using a sub 10 equals negative 310. Okay. We know that a sub 10 equals the first term, which we don't know yet, plus negative 30, the difference, times 10 minus 1. We know it's 10 minus 1 because we're grabbing that from the count right there. And we can swap out a sub 10 to negative 310 because they're equal. We're going to make that equal to a sub 1 plus negative 30 times 9. Negative 30 times 9 is going to be negative 270. And we need to figure out what a sub 1 is, so we're going to, of course, apply inverse operations by adding 270 to both sides. And when we do, we've now got our first term. It is a sub 1 equal negative 40. Great. So we've got the difference. We've got the first term. And now we need to plug it into our recursive equation formula. And so the template for this formula is right here. And let's plug in those values. So a sub n equals a sub n minus 1. This doesn't change. Plus the difference. We just found that out. Plus negative 30. And we found out the first term is a sub 1 is no longer equal to k. It's now equal to negative 40. Great. So what is a sub 2? A sub 2 is negative 40 plus negative 30. So this is the first term, right? Plus the difference being equal to negative 70. The third term is the second term plus the difference. It's going to give us negative 100. The fourth term is negative 100, which is the third term, n minus 1, right? Plus the difference, same every time, giving us negative 130. That is the fourth iteration. Let's try one more of these kinds of problems. So let's say we only know the 17th term and the 33rd term. We're going to pop in the final value minus the initial value over the final count minus the initial count. That's going to give us 128 over 16, which we can simplify to 8. Great. So we've got the difference. Now we need to figure out what the first term is. We're going to use our explicit equation formula. We're going to pop in our difference. We're going to swap out a sub 17 for 112, which we know because we're using this given information in the beginning, right? And when we multiply 8 times 16, that's going to give us positive 128. We'll subtract 128 from both sides. And now we've got the first term. It is a sub 16. And now when we go over to our recursive equation formula, and again, you need to always write this before we start these sorts of problems. We've got our common difference. We've got our first term. We know that the second term is the first term, negative 16, plus the common difference, giving us negative 8 as the second term. What's the third term? That's the second term, negative 8, plus positive 8, the difference, giving us 0. The fourth term is the third term, which we know is 0, plus the difference, giving us positive 8. 0, obviously, plus 8 is 8. We've got the fourth term. Nice. So this problem is a little bit of a doozy because we're going to be working with fractions. So let's say, hypothetically, the 18th term is 449 over 21. And let's say that the 34th term is 299 over 7. We need to get the denominators to the same right off the bat. We know that these have common factors. We can make the 34th term, the denominator, equal to 21 by multiplying both sides by 3. And when we do, 299 times 3 is going to give us 897, and 7 times 3 is going to give us 21. Easy, right? Easy breezy. So now when we look at it, we've got two values that have identical denominators, and we're ready to jump in and find out that difference using this formula, a sub f minus a sub I over f minus I. And when we do, we're going to get 897, which is the final value, which we got from right here, popping that in right there, minus 449. Let's go like that, and we'll go like that. All right, minus 449. And 897 minus 449 is going to give us 448. The 21s don't change when we're adding or subtracting, right? So now we've got 448 over 21, but we cannot forget the final count minus the initial count. So when we go back over here, we see that we've got 34 minus 18, right, from this term right here. And when we do that, 34 minus 18 is going to give us 16, and this is going to come across 2. So we have a fraction over a fraction, and what we can do is 448 over 21 divided by 16, and we can make this actually over 16 over 1. That's the same thing as what? How are we going to simplify this further? Well, what we're going to do is we're going to, as I wrote right here, multiply this by the reciprocal. So the reciprocal of 16 over 1 is 1 over 16. So we're going to take this new difference sort of on the top, we're going to bring it over here, times 1 over 16. And what I know is 448 divided by 16 is going to give us 28. 16 cancels out, it's just going to give us 1. And so when we multiply across, 28 times 1 is just 28. 21 times 1 is just 21. So what is this now? This is our new difference. A little bit of work to get here, but that's going to be critical as we continue in this endeavor. So now what we need to do, and let's not forget, so 28 over 21 is our new difference. Okay, I'm going to write that right there. 28 over 21, great. We've got our explicit equation formula. We are going to use the 18th term, which we got right there, 18 equal 449 over 21. And we'll swap out a sub 18 into its value, 449 over 21, equals a sub 1 plus the new difference that we just figured out times 17 or 17 over 1. We know this is n minus 1, which we got from right here. I'm going to change it to 17 over 1 because that's going to be a little bit easier when we're multiplying. So 28 times 17 is going to give us 476. 21 times 1 is going to give us 21. And now what we need to do is we need to apply the inverse operation. And we're going to need to subtract this fraction from the right side. And if we do it on the right, we're going to have to do it on the left. And so that gives us our first term. So a sub 1 is negative 27 over 21. Tremendous. All right, so we've got the difference. We've got the first term, which we have right here. We're now going to need to plug it into our recursive formula. So this is our template right here. When we plug it in, our difference is positive 28 over 21. First term is negative 27 over 21. And let's figure out what the second term is. So the second term is the first term, negative 27 over 21, plus the difference, giving us 1 over 21. The third term is the second term, 1 over 21, right, plus the difference, 28 over 21, giving us 29 over 21. And the fourth term is 29 over 21, which is the third term, the third value, plus the difference, giving us 57 over 21. Bam! This is amazing. You guys are doing great work. Let me know if you guys have any questions. Thanks.